It's something. Hello, can you hear me?
Yes.
How are you?
I'm good. How are you?
Fine, thank you. Only you is in so far. So let's wait for a while, see if other people will join us.
Okay.
No, I know this is Thanksgiving week. So that person is here now. Yep. Somebody else is joining us. So Dominic Brown. So we are three now. Let's say wait up to 6:15. See if others will join. Then we can begin. Are you guys getting ready for your Thanksgiving holiday? You have your turkey? Miss Terrell.
Not yet. Hey, Professor.
Hey, how are you today?
Good.
You have your turkey, huh?
No, I'm gonna go out and get it tomorrow.
Don't worry. Are you sure there's gonna be some left tomorrow at the store?
I don't know. Might have to get a Cornish hen.
Wanda is here with us. Like yesterday I went to the grocery store near my house. I couldn't even find a parking space. I was like it was around 4 o'clock, I believe. Everybody was rushing in, rushing out. And almost in every aisle you go to, the stuff there is almost gone,
Wow.
Yeah. People are really spending this Thanksgiving. I don't blame them. Yeah. Anyway, we're 5 now. Let's wait more. Let's make it let's 5 minutes we start so that we can cover enough ground. I know many people will be traveling out of state. Could be one of the reasons. But I like the holiday though. So we don't have to be in the campus. It's a long one. Tomorrow, Thursday, Friday, Saturday. Because I normally have Saturday classes too, but not this week.
Oh, wow.
Wow. Yeah, I have to have Saturday classes at a different college, Baltimore City Community College.
Oh, okay. I went there. That's where I transferred from.
Ah, what year?
Just this spring.
This last spring? Really?
Yeah.
Yeah, this last spring, the class they gave me was a business class.
Okay.
Yeah, but all these years, I've been teaching statistics there, statistics and algebra. Sometimes business class, but last spring and this semester, only business class. But next spring, I have a statistics class here, and then 2 business classes.
Do you know Kazim?
Kazim? Of course, I know Kazim. He teaches economics, right?
Yeah, in business classes like the entrepreneurship
Yeah,
class.
I know Kazim. He doesn't like to use PowerPoint, right?
He
Am I
does
right?
not-
Am I right
he's-
or wrong?
You're right.
He knows the stuff. He start in the class and then talk about it.
Yes.
Yeah.
Yeah.
He knows this. He's also a visiting professor at one college in London, UK.
Yes, he goes in the summer.
Good more time. Everybody in the business department knows Kazim.
I think so.
Yeah.
If you see him, you can tell him I said hello. He probably knows exactly who I am if you say my
I will. Of course I will. Kazim. He's full-time now. When I met him there the first time, he was an adjunct. Then later on, he became full-time. Yeah. Teaching him. So I think 5 minutes is gone already. So let us begin. Right? Is Dominic, you ready?
ready.
Ania, you there? Can you hear my voice?
Yeah, I can hear you.
Okay. I think I have Sharif too. Sharif, you there? Mr. Sharif.
Yeah, I'm here.
Okay, good. And there's one more person I need to send. Okay. See the Deshaun. Deshaun. Can you hear me, Deshaun? Okay. All right. Let us begin. What we have, somebody else joined. What we have today is test of hypothesis. Test of hypothesis for Carissa Fox joining us. Okay. So we finished confidence interval last week. Now we're looking at test of hypothesis. Now, a statistical hypothesis simply means a claim or a conjecture about a population parameter. So, when I say population parameter, I'm referring to things like the mean, standard deviation, or proportion. Now, that claim might be true or false, but we can't know until we test the hypothesis. Now, in a hypothesis testing, the researcher, first of all, define the population of interest, the target population, and then specify the parameter. Then next is to state the hypothesis that will be investigated, then give the alpha or the significant level. I'm sure you guys still remember alpha. We used it last when we were doing confidence interval. Then select the sample from the population. Then collect data, perform the test, and reach conclusion. Now, so many things can be, a lot of things we can test. Like if you still remember the time that we are trying to develop a vaccine for COVID-19, they run a lot of tests with, they call it clinical trials. So they still the hypothesis about the efficacy of the vaccine. Of course, they tested everything before they can bring it to the market. So some of the question can come in different form. It might be something like, does a particular medication lowers patient blood pressure? Or does seatbelt reduce the severity of injuries caused by accidents? Does the public or customers prefer a certain color in a new line of fashion? All this stuff are tested, and different questions. It can be any type of question. Now, let's look at the type of hypothesis we have. Each time you are running a test, a statistical test, there are two hypotheses to be tested. One is the null hypothesis, which is represented by the HO. A null hypothesis is a statement that the value of the population parameter is equal to a claimed value. And we normally write it using equal sign greater than or equal sign or less than or equal sign. These are the signs we use for null hypothesis. The alternative hypothesis, which we present with H1, is a statement that the parameter has a value that is somehow differs from the null hypothesis. A simple way of saying it is this. The null hypothesis says that the value, the parameter have a certain value. The alternative says the opposite of that. So actually, both of them are saying the opposite of each what the other one is saying. For the alternative hypothesis, we use these symbols, not equal to, greater than, less than, which means that you cannot use these symbols in the null hypothesis. And also, you cannot use the symbol in the null hypothesis in the alternative hypothesis. Okay? So at this point, we can now look at the error. If you remember from when we have the confidence interval, I explained that if you're 95% confidence, then it means that your chance of being wrong is 5%. If you're 90% confidence, your chance of being wrong is 10%. So your alpha is 10% or 0.10. If you're 99% confident, your chance of being wrong is 1%. And so your alpha is 0.01, right? Same thing with hypothesis testing. We call it the significance level, but we'll come to that in a minute. So that's chance of being wrong coming under types of errors. There are two types, type 1 error and type 2 error. In the type 1 error, we reject the null hypothesis when it is true. See? It is true, but we reject it. That's type 1 error. Okay? Then for type 2 error, what happened in type 2 error is that we do not reject the null hypothesis when it is false. Now, I'm going to illustrate these errors using a decision matrix or a chart. Okay? Let's say that this is the HO true, okay, HO false. Now, if HO is true, make sure you're seeing this. All right. If HO is true and we reject it, it is true and we reject it, as in reject HO, we have committed type 1 error. 1 error. You guys can see this, right? Can you?
Yes.
Okay, good. Now, if HO is false and we rejected it, we have made a correct decision. Okay. Now, if HO is, if it is true and we did not reject it, we made a correct decision. If HO is false and we did not reject it, see, do not reject, we made a type 2 error. Okay. Now we're human beings, so we are prone to errors. So this can happen. That's why we don't give 100% confidence interval. Only God or Providence can do that. We can say the maximum we can go is 99%. Pharmaceutical industries can use that because we're going to make sure that the medication they produce is effective. Now, let me illustrate this with a real-life example. I usually use our criminal justice system to illustrate this. You know, in the criminal justice system, when a defendant is brought to the court, right? The hypothesis testing can be likened to that. You know, a jury trial. Any of you been in the jury trial before? So you know what I'm talking about then, right? Yeah. So there are two possibilities. I'm sorry. There are 4 possibilities. The defendant is guilty. The defendant is innocent. The defendant is convicted. The defendant is not convicted. Now, all these things, depends on the evidence, the weight of evidence that the jury has. Okay. Now, if the HO now, the null hypothesis now becomes HO, the defendant is innocent. And H1 is the defendant is guilty. I can say not innocent, right? Okay, good. Let's look at it. Now, if HO is true, means that the defendant is innocent. HO false means that the defendant is guilty. Reject HO means convict. Do not reject HO means acquit, right? Now, if the defendant is innocent, which means that HO is true, and yet we rejected it, that means we convicted him or her. We have committed type 1 error. One error. And we know that this happens sometimes. In the past years, we have seen people who were convicted and spent some time in jail only to be released because DNA proved that they are not the actual culprits. If HO is false, which means the defendant is guilty, and we reject it, which means we convicted him or her, we have made a correct decision. Correct decision. Okay. I made a correct decision. Okay. Now, if the defendant is innocent, which means HO is true, and we did not reject HO, that means we acquit him or her, we have made a correct decision. Okay. Now, if the defendant is guilty, which means HO is false, and we do not reject it, that means we let him or her go, we acquit him, we have committed type 2 error. 2 error. See? You can see the type 1 error and type 2 error. So you can see that how we use it. You can use it in different ways. Now, remember that the decision of the jury do not prove that the defendant did it or did not commit a crime. The decision is based on evidence that they are provided. So if the evidence is strong enough, then the defendant will be convicted in most cases. But if it's weak, even though he or she did it, he'll be acquitted in most cases. So nothing can be proved absolutely, in most cases. So in other words, the decision to reject or not to reject the null hypothesis does not prove anything absolutely. See, not that it doesn't prove it, but it doesn't prove it absolutely. So the only way to prove it statistically, absolutely, well, close to that, is to use the entire population, which in most cases we don't have. Now, let's look at any question before we go to how to state hypothesis. Any question so far? Yeah, I'm getting the vibe that you guys are having fun with this, right? Anyway, let's see how we test hypothesis. So the first thing is to state a null hypothesis and an alternative. Don't forget that for the null hypothesis, we use this symbol equal to, greater than or equal to, and less than or equal to. For the alternative, we use not equal to, greater than, and less than. Okay? So having said that, I can now take you, say, look at this question. It says, state the null and alternative hypothesis for each conjecture. Or I can call it for each claim if you like. For each claim, okay, let me just leave it at conjecture, but you know that. He said, a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. See? And then the average birth weight of the population is 8.6 pounds. So when you say that it will increase, given that the average birth weight is 8.6 pounds, you mean that it will increase means that it will be bigger than 8.6 pounds. Remember, he said, if they use these pills, the birth weight of the babies will increase. That's the key word right there, will increase. See? Will increase means greater than. Am I right or wrong? Right? So, and they say the average birth, the birth weight, the average birth weight, say the average is also the part of the key. So the average, I mentioned that this is the test for the mean. So we can only use greater than in the alternative. So we're gonna put it there and say it, mean. Okay, mean is equal to 8.6 pounds. Sorry, mean is greater than, because say we increase, greater than 8.6 pounds. That's what he's claiming. 0.6 pounds. So that's his claim. Okay. Then the alternative, the null hypothesis will be say the opposite of that, always. And that is going to be less than 8.6 pounds. But the problem is that we cannot use less than symbol on the null hypothesis. So we're going to use less than equal to. Mean is less than or equal to 8.6 pounds. See? So that's the first thing, how to state the hypothesis. So that's where the hypothesis have now been stated, not an alternative. Any question on that? Excuse me. All right. Good. Now, look at another one. It says, some books might say to write it this way. So into some textbook, they might say, okay, mean equals, you might use equal sign, 8.6 pounds. Then on the alternative, we use the same thing, because we increase. See? Some books, they are both correct. Okay. But I prefer this one, to be on the safe side, use this one. This one is more accurate. Okay. Let's see. Now let's try this another an example. It says here, an engineer claimed that the mean number of defects can be increased by.
Hi, sir.
Is it Otto? Is it Otto?
Yes, I was having problem with my internet.
So what's your last name again, Otto?
Otto Lawson, Lawson.
Okay, I got it now.
Okay, thank you.
Welcome. See, an engineer claimed that the mean number of defects can be decreased in a manufacturing process for compact discs by using robots. See, and instead of human beings for certain tasks. The mean number of defective per 1,000 is 18. He said that the mean, that's the keyword, the mean, that tells you that this is the hypothesis for the mean of defect can be increased, can be decreased is another keyword. See? That's another keyword right there. Can be decreased. Okay. So having these two keywords, now you know what to do. Now I said can be decreased. Decrease can be used only, the symbol decrease, less than can be used only in the alternative. So you're gonna put mean, okay, decrease less than 18. To the claim, okay. Then the alternatives say the opposite, which we're gonna be greater than. But the problem is that we cannot use greater than symbol in the, sorry, no hypothesis will be saying the opposite, which is greater than, but we cannot use greater than symbol in the null hypothesis. So we have that mean greater than or equal to this time around. Okay, you're gonna put the mean right here. Oh, excuse me. Mean greater than or equal to 18. Okay. All right. Any question on that? No, any question? Oh, okay. That's one thing I want to let you guys know. Okay, I will explain it when we start. I will get to that point. Next one is this. A psychologist says he feels that playing soft music during a test will change the result of the test. The psychologist is not sure whether the grade should be higher or lower. In the past, the mean score is 73. So playing a soft music during a test will change the result. It doesn't tell us whether it will be increased or decreased. Just say that it will change it. And that in the past, the mean score was 73. So we change. It doesn't tell us the direction. For that, we use not equal to for that. Okay, because it didn't tell us whether it's going to decrease or increase. So we're going to use not equal to. So it doesn't, no direction was shown. Mean equals 73. Claim. Okay. And H1 will say the opposite, which is, and HO will say the opposite, which is mean equal to 73. See? Yeah. All right. Look at this one then. See, at least 45% of senior citizens wear hearing aids. At least is a keyword there. At least, which means greater than or equal to, which can only be used in the null hypothesis. Then percent means that it's a proportion. So you're going to have P greater than or equal to, that means at least 45%. That is your claim right there. The opposite will be P. So you cannot use mean, you're going to use P because this is a proportion. P is less than 45%. See? Yeah. Yeah. Any question on that so far? Any questions so far? Okay, good. Good. I think we have two more before we now go to the actual testing. My file says more than 70% of college employees contribute to United Way. More than 70% of college employees contribute to the United Way. So more than means greater than, which we can only use in the alternative hypothesis. So that means more than, that means P is a percent, that means it's a proportion. P is greater than 70%, which is the claim. Okay. Then the opposite is that P is less than 70%, but we cannot use less than in the null hypothesis. We can only use less than or equal to. So you gotta be P is less than or equal to 70%. Okay. And the last one will, I mean, this is to familiarize you on how to state the alternative hypothesis to get you comfortable with that. Let's look at this one. It says The average annual income of accountants is 51,497. So we have our HO, and H1. And the H1. Yeah. So it's a average, see the average, annual average, this average is the key. Is another key. Is means equal. So you have HO, we have at the mean equal to 51,497 as our claim here, because you say is. Yeah. The alternative hypothesis will be opposite of that. That mean is not equal to. Mean, okay, is not equal to that amount. 51,497. Any question on this? Good. Now, I recommend that you try as many as you can when you get the chance. Maybe this number 7, you can try it by yourself. The average age of Anton is greater than 25.4 years. So you can try that. Let's look at some of the terms we use in testing hypothesis. The first one is level of significance. The significant level simply means the probability of committing of rejecting the null hypothesis when it is true. That means that the significant level is the probability of committing type 1 error. We use alpha to represent that. The critical region is just the rejection region. If your answer falls in the critical region, you reject the null hypothesis. If it doesn't fall in the critical region, you don't reject it. So critical value is not like the cutoff point, just cutoff value for the critical bit that separate the critical value from the non-critical, the critical region from the non-critical region. Okay, we're going to see this as we proceed. Now let's look at the types of tests. We have 2 tail tests and 1 tail test. So you can, I'm sure you remember the tails when we are doing using a table of normal distribution. So this one have 2 tails. If your answer fall in this tail, in the right tail, you reject. If you fall in the left tail, you reject. But if it falls here, this is the acceptance region, you don't reject. For example, this one we just did, equal to and not equal to is a 2-tailed test. 2-tailed test. Because it can be either on the left side or right side. Okay. Now, another one is the left tail test. This is on the left tail. I think we did an example on the left tail. When you use less than, you mean you're looking at the left tail test. You can see it from here. See, this one is the left tail because it's say less than. That means it's pointing on the left side. See, left tailed test. Tailed test. Okay. Now the other one is the right tail test. See, right tail. See the critical region right here on the right tail. I think we have that one too. When we use greater than, you're referring to the right test right here. See, this is right tail test. Right tailed test. Okay. Now, at this point, we can now review the z-test for the mean. For the z-test for the mean, there are 2 methods, the traditional method and the p-value method. We are going to look at both methods for testing hypothesis. For the traditional method, the steps are as follows. You state the hypothesis and then identify a claim, find the critical value from the appropriate table, then compute the test value. That means run the test. When you finish running the test, you compare your answer to the critical value and then use it to make decision to reject or not to reject the null hypothesis. Then summarize their results. Now, how do you make that decision? We reject null hypothesis if and only if the calculated value is equal to or exceed the critical value. Otherwise, don't reject. And this is the test statistic we use for that. Z equals sample mean minus population mean divided by the standard deviation over the square root of the sample size n. So where S bar is the sample mean is the population mean, delta is the population standard deviation, and n is the sample size. Okay. Let's do some examples here. It says, okay, let's see. Okay. Maybe I'll move this to the second line so that we have enough room for it. Okay. I'm gonna move it to the second line so I have enough room. So let me move this question. So look at the question right there. It says here that there is a researcher report that the average annual salary of assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, test the claim that assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. So let us do this. Remember, the first step is to state the hypothesis and then identify the claim. We'll begin from there. So I'm going to make this to be bigger. Oh, we need to have a second workbook so that we can now get some characters we cannot get from this current workbook. So we can get some of those characters from the new workbook. So I'm going to make this in bolder. Make it more bold. Okay, make it 16. Okay. Get down. You say that, let's begin. The first thing it says is to state null hypothesis and the alternative hypothesis, HO and H1. Okay. The null hypothesis says, a researcher reported that the average annual salary of assistant professors in the year 1997 is more than $42,000. $42,000 per year, of course. A sample of 30 assistant professors has a mean salary of 43,260. And alpha 0.05 tells the claim that the assistant professors earn more than $42,000 a year in 1997. The standard deviation of the population is 5,260. Now, somebody might say, this sample of 30 professors gave us an average salary of 43,000, right? 43,260. So, and we are making the claim was that their salary is more than 42,000. So somebody might say, okay, so we have 43,260. So that means why are we doing the test since 43,260 is bigger than our claim? No, but we have to do the test because that number was gotten from only 30 assistant professors. They don't represent the entire population of assistant professors. So, and we have the population standard deviation too. That's why we have to proceed with the test. So the keyword again, you can see that they say that they earned more. See, they earned more than. See, they earn more than 36,000. See, that's the keyword there. So then we have that mean. Let's start by putting the mean. So more than. So more than is equal to greater than. So we're gonna put greater than for that because it's more than. So mean is greater than 42,000. Okay. 42,000. That's what they said. This is the claim. Then the opposite is the mean is less than 42,000, but we cannot use less than symbol in the no hypothesis. We can only use less than or equal to. So we have mean less than or equal to 42,000 plus. Okay. So, and our alpha is 0.05. Okay, alpha is, let me just get it from there. Alpha is 0.05. Okay, I'm going to take it from here. Alpha is 0.05. See? So now with that, we can get our critical value. Yeah, critical value. Critical value. Now we have done critical value before for confidence interval. What we use Z alpha over 2 for critical value for confidence interval. But now this time around we're doing only we're doing a one tail test, that's the right tail. So we can't use alpha over 2 because it's a right tail. If it is two tail test, we use alpha over 2. Now in that way, that means we're gonna use the same method we use for finding the critical value for confidence interval to find the one for test of hypothesis, if and only if it is a two-tail test. But in this one that has this one is a right tail test. You have to use it, follow this method, and you're gonna write only Z alpha here. Some books write ZC equals now because it's a right tail test. So if you remember the procedure chart, when it's at a tail, you subtract the value from 0.5. So we're gonna do 0.5000 minus the alpha is 0.05, and that will give us in the calculator. I'm gonna take you to 0.5. Okay. What is our calculator? Okay, it disappeared. I'm gonna find it. Don't worry. The calculator is somewhere hiding. Let's see. Right there, it's right here. Okay, I'm gonna put it back in. Okay, so let's say to get the calculator. We have it right here. So 0.5 minus 0.05 is 0.45. So we're gonna put it right there. 0.45, 0.45. 0.45. Now we can now go to the table of normal distribution. If you remember I mentioned it in the class to print that table and look for 0.4500. Now this is because it is that table have only 4 digits, so make it 4500. Okay, I'll go and look for 0.4500 in that table, which is right here. Remember, this is the correct one that you use. Table 5. Area under the standard normal curve. 0.4500. I have two numbers closest to it. This one is 0.4495, and this one is 0.4505. Each of these two numbers are equally close. This one is 5 points away. This one is also 5 points away. So I remember I mentioned in the class, if they are equally close, to use the bigger one, which is this one. And then follow it to the left. 1.6 up 5. So our critical value is 1.65. 1.65. So we have stated our hypothesis. We now have our critical value. We're now ready to run the test. Let us run the test. So to run the test, we need more values. We are told that this is the claim was that the salary of assistant professors in the year 1997 is more than the average salary is more than 42,000. That means mean, okay, equals 42,000, and that's a sample of 30 assistant professors were selected. So N is 30. Yeah. Then of this 30, the sample mean is 43,260. I don't have the character for sample mean, so I'm gonna get it from the other workbook. So let's say that's X bar. I mean, sample mean is the X bar. And let me write these things down on this paper so I can. So our X bar, we have our mean is 42,000. N is 30. So S bar, which is the sample mean, is 43,260. So we can go and get it from that the character from the other workbook. So the sample mean, we have to insert our X bar, which is this X bar. I'll make this in bigger. Oh, excuse me. Let me make it larger. Probably 18 or 16. 18 will be better, I think. Okay, sample mean, okay, equals 43,260 from the question. We got it from the question. So now I'm gonna copy this and paste it in our main workbook. Okay. Okay, that is the sample mean right there. Now, this population standard deviation according to the question is 5,230. So that the population standard deviation equals 5,230. So all these things that we need to have, okay, have them. Then we can now get we can now run the test. Remember, the formula for running the test is this: Z equals X bar minus mean divided by standard deviation over root n. So let's go and put these numbers in that formula. We have the mean and S bar standard deviation. So let us run the test. So that we call it the test statistic. The test statistic is, now let's go and put them in. Since we can get the formula character for the formula in the other, I'm gonna take you there. Z equals we got X bar okay, minus the mean, population mean, which we can get from here, divided by the standard deviation over root n, and we can get the standard deviation from here over the square root of n, so that we have equals our S bar sample mean. If you remember, we have all these numbers already here. Don't forget, we have them all here. Some population mean, N is 30, sample mean is 43,260, and then the standard deviation is 5,230. So we put them into we insert them into our formula to get this. Sample mean is 43,000. Oh, you know, I forgot to write down the population standard deviation. Let me write it down, then we can put them in the formula. Delta is 5,230. Yeah. So let me go and put them in, and we can get our answer from there. We have 43,260 minus 42,000 divided by standard deviation by the square root of n. Standard deviation of 5,230 over the square root of n, and our n was 30 assistant professors who we are interviewed, equal. So let's go and put this in the calculator. I'm going to write this down. Z equals 43,260 minus 42,000 over 5,230. 5,230 over root 30 here. just to be sure. Okay, just to be sure, have this. Okay, make sure. Yep. So let's go and put this in the calculator. All this in the calculator. Have my calculator right here. So have 43,260. Yeah, somebody's joining us. 43,260. Oh, excuse me. 43,260 minus mean of 42,000. Okay, divided by the standard deviation of 5230 over the square root of 30. We get 1.3195156, just 1.32 rounded. So 1.32 rounded. Okay, 1.32. 1.32 is the result. So we run the test, we get our result as 1.32. So we're gonna paste it in our main workbook. And then, so our test is run and we got the result 1.32. See? Now, with this, we can make a decision. How do we make the decision? We compare our results with the critical value of 1.65. So let's make the decision here. Okay. Okay, let's see. Decision. I'm gonna make this to be bigger, more bold. Okay. Make it 16. Decision. Let's see. This one says, see, we have the critical value we have. Critical value. Okay. I'll make this in bold. Make it 16. Critical value Z alpha. I think I'm gonna make it 18 because 16 is too small for our screen. Make it I made this 18. Critical value Z alpha. The alpha right there by the side equals what we got for our critical value was 1.65. See, 1.65. Then calculated value, that means our answer, calculated value Z equals our answer. The answer we got is 1.32. See? Now, what would be our decision? Now, remember, I explained that the decision criteria goes as follows. Reject the null hypothesis if the calculated value, the answer, is equal to or exceed the critical value. Otherwise, don't reject. In this case, we compare the two. This is our answer right here, the calculated value, and it's less than the critical value. So we cannot reject null hypothesis. So what we're gonna do is say the answer is do not reject. Do not reject the null hypothesis, which is HO, because the calculated value of 1.32 is less than the critical value of 1.65. See, you do not reject because it is less than the critical value, which means that we did not reject this. If you don't reject this, that means the claim is incorrect, since we are accepting this one. So the answer now becomes, because remember the claim was that the salaries of assistant professors is in 1997 was more than 42,000. So since we are rejecting the claim right here, more than, since we did not reject the null hypothesis, that means that this claim is not correct. So we can conclude that there is there's not enough evidence to support the claim that that assistant professors earn more than 42,000. So let me just make it faster. There's not enough evidence. Let me copy this. Let me make it faster for us. Now, so the conclusion now will become conclusion. Yeah, there is insufficient evidence to support the claim. The claim that the to support the claim. Okay, to support the claim. Okay, let's start from here. That's assistant professors earn more than 42,000 in that year. Okay, there's not enough evidence to support the claim that they earn more than 42,000 in 1997. There's not enough evidence to support it. So that's we have tested the hypothesis. See? So remember what we did. We stated the hypothesis. We got our alpha. We got our critical value. We write down the summary statistics. We run the test by putting them in the formula. Then we finish the test, then get our result as 1.32. Then we make our decision by comparing our answer to the critical value. Because our answer is less than the critical value, we don't reject no hypothesis, which means that we don't reject that it is less than 42,000. Instead, we reject the claim that it is greater than 42,000. And then we make our conclusion that there is not enough evidence to support the claim. Any question to that? Any question? Yeah, good. Now let's do another one. This one is a right-tailed test. Let's do the one that is not right-tailed, the one that is two-tailed test. Okay. All right, let's see. We have this question here. Yeah, I'm gonna make it bold. Yeah. I'll have that yeah, let me make it from here. Make it bold. Oops. Okay, yeah, make it bold. Make it 16. That should be enough. So the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,620. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from 24,672. Yeah. Now, how do we solve it? Again, like before, we stated no hypothesis. Our solution. Yeah. HO, we just study HO, and H1. Okay. It says here that the average cost, okay, the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,672. To see if the average cost of rehab is different, a particular hospital is different in a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and then find that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,521. At alpha 0.01, can it be concluded that the average cost of can it be concluded that the average cost on at a particular hospital is different? See, the average cost is different. Is different. See, is different means not equal. It doesn't tell us whether it is less than or greater than. So it's different. So it's different is right there, the average cost. So that will give you the keyword right there to state your hypothesis is different. Okay. So now what you're gonna do is to state the hypothesis. See, different means that it's not equal to, and we can only use not equal to in the alternative hypothesis. So you're gonna put this right here. Different, not equal to, okay, not equal to 24,672. Okay. Then no hypothesis will say the opposite of that. So you have that I think I'm gonna move this down because this space is not be enough for us. Let me move it down. Okay. Yeah. Yeah, so we can have enough room. Yeah, good. So HO now becomes mean. The opposite mean is equal to that. Is equal to 24,000. Excuse me, 24,672. So the claim is that is more than, is different. So we have here claim. Okay. Now we can now run our test. Our alpha. They told us that at the alpha, they give us the alpha right here. So that alpha is 0.01. So I'm gonna highlight it and copy it from there. 0.01. So that the probability of committing type 1 error is 0.01. So let's find a critical value, Z alpha. Now, because this is, remember, this is it said equal to and not equal to. This is a two-tailed test. So for two-tailed test, we use the same method that we use to find the critical value for confidence interval to find it. If your alpha is 0.01, that means your chance of being wrong is 99. Sorry. If your answer is, if your alpha is 0.01, your chance of being wrong is 1%. So your confidence level is the significant level is your confidence level is 99%. I mean, it's gotta be 99. This is a shortcut for getting it. 99 over 200. Or you can use I will show you both methods you can use. 99 over 200, which give us on the calculator, we have 99 over 200. 99. We did it when we are doing confidence interval, which is 0.4950. 0.4950. 0.4950. 4950. Now we can get it from the table of normal distribution. 0.4950. We can go and look for it on this table. Okay, 495. We have 4950. The closest I see 4949 and 4951. Both of them are equally close. So we use the bigger one, this one here. 4951. Follow it to the left. 2.5. 2.58. Yeah. So the critical value is 2.58. 2.58. Yeah. Now another way you can get is if you don't want to use this shortcut method, is to write Z alpha. Z alpha. Because now actually it won't be Z alpha anyway. It's gonna be Z alpha over 2. Because it's a two-tailed test. See? Equal and not equal to is a two-tailed test. So you're gonna call it Z alpha over 2. Okay. Equals now 0.500 minus now alpha over 2 means 0.01 divided by 2. Okay. Actually, you don't even need to subtract it. 0.01, but yeah, of course. It's gonna be 1 minus this. Excuse me. Give me 1 minute. Let me check this from the calculator. Let me double check this from the calculator. You can have 1 minus 0.01 divided by 2. Okay. Now we're gonna use okay, close it. 0.5 is better. Since we're using this table, we're gonna use 0.5. Okay, now what we're gonna use, so what we're gonna do is this, all right? We have 0.5 minus 0.01 divided by 2. And that will give you your value that we'll look for in the table. So we go and do 0.5, we have it here, 0.5 minus 0.01 over 2 give us 0.4950, which is what we got before. 0.4950, 0.4950, which on the table give us, if you go to the table, you get the same answer, which is 2.58. See that way. But remember, this is the shortcut method, so that's why I use it a lot. So we have a critical value of 2.58. Now, to run the test, we get the summary statistics. Instead, the question says that we have that the average cost of rehabilitation for stroke victim is 24,672. Let me write this down. The sample mean will be average cost 24,000. Let me put it in. Equals 24,672. Then the population sample mean I can get from the other workbook. Mean is 24,672. Then S bar, which is sample mean, he said that it is 25,000. See, the researcher selected a random sample of 35 stroke victims. So N is 35. 35. And that 35 happens in a hospital, and find the average cost to be 25,000. The sample mean, that is average mean for the sample, 25,226. 25,226. And N is 35. So let me go and get it from the other workbook, because it has the character S bar. So our X bar we're gonna be equal 25,226. So I'm gonna copy this and paste it in our main workbook. Okay. Then the standard deviation of the population, they say that the standard deviation is 3251. Okay, 3251. So let me write it down. The standard deviation for the population equals 3251. Adjust this. So with this small statistics, we are ready to find we're ready to run the test so that we can write that the test statistic is, okay, use our formula. Let me write this down. We're gonna put it in. I have the summary statistics on my book written down. Let's go and get it. The test statistic for this is Z equals X bar minus mean, X bar, okay, minus mean, excuse me. All right, minus mean, and the mean is from here. I can get it from this character, divided by the standard deviation over the square root of n, divided by the square root of n, okay, n. So that we have equal to the S bar is something in 25,226 minus population mean of 24,672 divided by the standard deviation over root n, the standard deviation of 3251 over the square root of n. Now n is 35 people that have stroke in that hospital. So let's go and plug this in our calculator. Let me write it down. Z equals 25,226 minus 24,672 over 3251 over square root of 35. So you can go and put this on the calculator. See the result it will give us. So we have, I'm going to clear this, 25,226 minus 24,000, okay, 672 divided by standard deviation of 3251 over the square root of 35. I think I missed something. Oh, 35, sorry, 35. 1.00815, basically 1.01. 1.01. 1.01. Okay. 1.01. So we're gonna copy this. Okay. And then paste it in our main workbook. Okay. Actually, it's right here. So, yeah. So we have run the tests. Our result is 1.01. Now we're ready to make decision. Okay. Now let's make decision. Decision. Sean. Okay. Critical value. Critical value. Value Okay. Oh, excuse me. Z alpha over 2. Z alpha over 2 equals, remember, this is for decision. I'll make it bold. What we got for critical value is 2.58. 2.58. Calculated value Z. Value Z equals, you got it 1.01. So what will we decide? Now we compare the two. Our calculated value is less than the critical value. So we do not reject. Do not reject the null hypothesis. It's HO because the calculated value is less than a value of 1.01 is less than the critical value of 2.58. So now if our answer, let's say we got 2.71 here, which is bigger, that means we're gonna reject. But as long as our answer is less than or equal to the critical value, we don't reject. So that means we did not reject null hypothesis here. See? So that means the claim is incorrect. So our conclusion now becomes conclusion. Yeah. There is not enough evidence. There is not enough evidence to support the claim. The claim that claim was that the average cost of stroke rehabilitation, the average cost of stroke rehabilitation here at the hospital is different from 24,000, is different from 24,672. Okay, this is based on a sample of 35 stroke victims. Any question for this? Any question? Hello, scholars. Are you guys sleeping already?
I do have a question. You said in the for the critical value and the calculated value that if that was 2.78,
yeah,
that there would be a difference. And why would that be?
Because
why would we reject it then?
Because the decision criteria is that if the answer you get is bigger than the critical value, you reject null hypothesis. Let's say that if our answer here, for this one, let's say the answer is 2.8, right? Which is bigger than 2.5. In that case, we will reject HO. That means that the claim is correct. In that case, our conclusion will now become that there is sufficient evidence to support the claim that the average cost of stroke rehabilitation at the hospital is different. Okay. But since our answer is less than that, we cannot say that because we did not reject null hypothesis. So in that case, the claim is not correct. That's why we concluded this way. We concluded.
Okay.
Yeah, good. Any other question on this? Well, I guess you guys There's another type we want to do is z-test, the p-value method. In that case, the decision criteria is a little bit different. In that case, if the p-value is less than alpha, we reject null hypothesis. But if the p-value is greater than alpha, we don't reject null hypothesis. So I would say we do that one. We'll come back from break, from the from the holidays, Thanksgiving holiday. Okay. So enjoy your holiday, and I'll see you guys next week.
I got a question for you.
Yep. What question? Go ahead.
Did you get my email that I sent to you?
When did you send? I replied to some emails yesterday. What's your name?
Dejan
Last name?
Winder.
No, I didn't see that. I didn't see that email. But you can tell me now. What's up?
Yeah, it was about the missing work. You just say email you the ones that I'm gonna do, and I just was letting you know. I wrote them down in the email and just told you which ones I was going to do.
I told to send the email of the homework or the classwork?
Classwork.
Okay. So you say you send the email. When did you send it again?
I sent it. Let's see.
I don't remember getting an email from you. Why in the addition one? Why in the right?
Yeah.
I didn't get the email. But in any case, let me look at your attendance. See if it's good. How many you missed?
Like 4.
4 classworks?
Yeah.
Okay. Now, send me the names because each of them have a name. This email you mentioned. My email, if you can't send it, I recommend you send it with go to your school email. My email is the syllabus. I think I have it here. Use that to send it direct to me.
Okay.
Course. Okay. What is my course syllabus? Right here. So open it so you can see my email there. Use that email. Then I'll look at the attendance and see. We go from there. So the syllabus. Let me show you the email I'm talking about. See, it's right here.
I said I can't see it.
You can't see it?
No, it's still on the classwork that you were showing us.
Oh, okay. Let me.
Can you add this to the modules, Professor?
What was that?
Can you add these notes that you just did to the modules?
Oh yeah, sure. If you want that, I can do that.
And I just have a quick question about the project. Do we have to transpose everything on a Word document that you uploaded, or can we submit an Excel file?
Well, that is an important question. You do it in Excel, then you copy it and paste them in the Word document.
Okay.
Now, the ones that you cannot copy and paste, you leave it on the Excel file so that you submit both files. But then you go to the Word document and refer that mention that see Excel, mention where the location it is in the Excel file so I can see it. Okay.
Okay.
But the writing part of it, the conclusion, you have to be written on the Word document. Okay. Now, Mr. Winder, can you see it now?
Yeah.
That's the email, my email. So let us send it, then I'll look at the attendance and then we'll go from there.
All right. I had good attendance. I think like 89.
You sure?
Yeah.
Okay,
we had talked about it last week in class.
Okay. Let's see then. Winder, right?
Yeah, it's all we at the bottom.
Oh,
yeah.
Oh, that's good. That's good. Okay, then send it then.
All right, I got you.
Send it. So any other question before we leave? Okay, they want me to upload this. Okay.
I wanted to see if you could look at 2 of my assignments I turned in.
I'm gonna grade them. Don't worry. This past few weeks I was behind. and my grading. But now we have a brief holiday. I'm gonna use it to catch up. Okay.
Okay, thank you.
You're welcome.
Happy Thanksgiving, Professor. Enjoy your holiday.
Happy
You too.
Thanksgiving.
You too. You guys enjoy your holiday. Have a nice evening.
Bye bye.
Okay. Bye bye.